Okay, welcome back. Lesson 31, problem solving and interest problems. So I'm happy to present some subjects that we can all relate to, right? Student loan debt, car loan debt, mortgages. So we can get familiar with how these monthly payments are computed and what exactly interest means. So let's dive in. Interest is money charged for using other people's money. Money borrowed, loaned, or invested is called the principal. The interest rate is the percent used in computing the interest, and it's usually per year. Simple interest is interest computed on the original principal. So let's go ahead to the next slide. Simple interest, which is principal times rate times time, and we'll use the formula you'll hear us talking a lot about, I equals PRT, is our formula that we're going to use to compute the interest that accrues on, let's say, a car loan. And this is true. So if you walk into the bank and say you want to take out a loan for such and such amount for a car, they're going to use this simple interest formula. So we actually have a practice problem right here that we'll work through together. So the rate is understood to be per year, and time is in years. If you're reading a word problem in a textbook or on a test, let's say, and time is not given in years, make sure you, like say it's given in months, make sure you convert it back to years. So big note to self, must be in years. Okay, for simple interest. So suppose I walk into a bank and ask for a car loan for $11,000. I've done this before, to be paid back in 5 years. Now, sometimes they'll say, would you like to take it out for the loan out for 5 years, for 7 years? Usually they have a cap on how many years for the car loan. To be paid back in 5 years at 5.5% simple interest. What is my monthly car payment? And of course, for this financial segment, we may use a calculator. So I know most of the course we have not been using a calculator, but when we get into this part of the course, I let my even live students use a calculator. So all right, well, let's grab our formula for computing interest. We know, I have a hint over here, that total amount due on the loan is your principal plus your interest. So let's go ahead and figure on the interest. We know the principal is $11,000. That's how much we're borrowing. So principal, $11,000 times rate. Notice I'm going to put 0.055. Principal times rate times time, 5 years. So I'm going to go ahead and compute that. And let's go ahead and type that out. So 11,000 times 0.055 times 5. So we have our interest is $3,025. So let's put that down. So 3,025. But now we want our total amount due. So I'm going to write that out. So total due is the principal, the original amount borrowed. So it's 11,000 plus the interest that will accrue, assuming we take that full 5 years to pay off the loan. So of course, basically they don't want you to pay it off early because they're going to make money off of us, right? So then the grand total would be, so you think you're taking out 11,000, but in reality, they're making more off of you, right? So 14,025. All right, hope that helps. I'm going to hit pause a moment as we go to the next problem. Okay, compound interest. Now we're going to take a look at compound interest. Compound interest is what you're probably going to see with your student loan debt. It is computed on not only the principal, but also on the interest that has already been earned in previous compounding periods. If the interest is compounded annually, that means once a year, on an investment, this means that the interest is added to the principal at the end of each year, and next year's interest is computed on this new amount. So thankfully, there's a formula for that. Sorry about that. There's a formula for that, and we will be using this formula, which is in the Martin Gay textbook. The total amount A in an account is given by, I like to think about this as future value of the loan. Okay? I like to think of this as future value of the loan is equal to principal times 1 plus the rate over the compounding period and then raised to the NT power. That's compounding period times the time. So we are told here what all the variables are. P is principal, R is interest, T is length of time in years, and N is the number of times compounded per year. So again, big note to self, don't get tricked. You want time to be in years. So if it's said in months, we'll just convert it to years. Okay, so let's take a look at this problem. Suppose I invest $3,000 in an account earning 6% interest compounded semi-annually. How much money will be there at the end of 20 years, assuming no more deposits were made, and may use calculator? All right, so I like to write this as future value of my investment equals original amount invested 1 plus R over N to the NT. I always start off by just sort of regurgitating the formula, which is given above here. I just use slightly different variables. If that messes you up, I was going to say that. I'll stick with the same variables that are given in the text. A is future value of the investment, and we'll stick with the same variables, and P is principal, amount borrowed or invested. Okay, so let's fill in the blanks. Okay, so 3,000 is the amount invested. That's our principal. And then 1 plus R is our rate, our interest rate, which is 6%, but as a decimal, that's 0.06, divided by the compounding period, which they say is semi-annually. So note to self, semi-annually, N equals 2. So put a 2 for N. You notice up here the N appears as well. So 2 times however many years. Well, it says how much is going to be there at the end of 20 years. So 20 for T. All right, now the big thing that happens to my students, even in my live class, is they have trouble with order of operations and actually typing this into the calculator. So let's make sure we can do that. Please excuse my dear Aunt Sally, right? It says to go inside the parentheses first and to do division before you do addition. So you do it in pieces. Okay, so I would not recommend typing it in one big string. So 0.06 divided by 2 is something, plus 1 is something. And then up caret, raise that to the, well, 2 times 20 is 40. So we can raise that to the 40th power. And then eventually multiply it by this 3,000 here. So times 3,000, 9,786 and some change. So I'll take off the change there, but so okay, so approximately 9,786. So the money has more than tripled, and that's without even, putting any more into it. So that would be how much is there after 20 years. So again, the big thing is setting up the formula correctly and then typing it into the calculator correctly. So you can see all the pieces of the puzzle right there. Okay, so just familiarize yourself with what goes where, and I'll just reiterate that one more time. Principal, R for rate, which you want to convert your rate into a decimal if it isn't already. N for compounding period, which may be monthly, semi-annually, quarterly. Now you may want to make a little like cheat sheet to yourself over here. I did want to mention that. 2 for semi-annually. N is 2 if you're doing semi-annually. N is 4 if it says that the interest is compounded quarterly. Obviously, there's 12 months in a year, so N is 12 if it's monthly. And then daily, 365, weekly, 52, etc., etc. So you may want to just remind yourself, big note to self, that N varies. depending on what they're saying in the problem. Okay? But I have faith that as long as you plug everything correctly into this formula and type it out correctly, you'll be okay. All right? And now this last problem, I think, will be very interesting to you because I have student loan debt. You are probably going to have student loan debt. So let's take a look. And I'm actually using numbers that are pretty accurate in terms of my student loan debt. Suppose I have $30,000 in student loan debt, and Sally Mae, which is now Navient, they take over your student loan debt and you have to pay them back. It's kind of like a mortgage. They take the debt and ask me if I'd like to pay it back over 15 years or 30 years. So I tell them 30 years thinking my monthly payments will be lower. This is true. I'm telling you the truth. If I take all 30 years to pay back the loan, what is the future value of my loan? In other words, the total amount given to Navient over those, after those 30 years. And assume 5% interest compounded monthly. Now that part I don't know. I do know that they use compound interest formula. I don't know that it's monthly. And you'd have to call and find out what your personal interest rate is. But okay, you'd be surprised at how much money they're actually making if we take 30 years to pay off the student loan debt, and making a lot of money off the interest accrued. So what's my monthly payment look like? All right, let's take a look. Okay, so let's first start off with the formula. Oops, sorry, my pen's being fussy. So A equals P 1 plus, always just start off by reciting your formula, 1 plus R over N to the NT. And then just kind of fill in the blanks. So I have $30,000 worth of debt, so P for principal. Okay, so $30,000. And then 1 plus, my interest rate is 5%, so that's going to be 0.05 as a decimal. Divided by my compounding period. Well, look out for the words, here it's compounded monthly. So monthly is going to be 12. Compounded monthly. And then again, you see that N in the formula, so 12 times the time, well, we're taking 30 years to pay it back, so times 30. That's actually going to be the total amount due, or the future value of the loan. All right, so let's grab this, I'm circling it, and type it out. Once again, this boils down to, are you typing it in okay? Okay, so 0.05. Notice I'm going inside the parentheses first, divided by 12, doing order of operations. Okay, plus 1. And then up caret, raised to the 12 times 30. And you can type out 12 times 30 if you want. Okay, enter. And all of that times this 30,000. And whoa, 134,032 and some change. So let's 134,032. Let's record that. Wow. So we think we borrowed 30,000, and over the life of that loan, look at that, 134,000. So they're making a lot of money, right? But we still haven't answered the question of monthly payment. So let's just kind of write this out. 30 years, and there's 12 months in a year, so let's take that times 12. So I want to answer this question of what's my payment going to look like. So let's do some calculations here. Okay, 30 years times 12 months in a year. Okay, and then this is the total amount due on the loan. So we're going to have to take the 134,032 and divide it by 360. And we're looking at about a monthly payment of $372. And that's about accurate. So 372, approximately $372 for your monthly payment. Yay. So if you're thinking, wow, that's like a car payment or more. Yes, this is true. But I always say student loan debt is good debt. So it's worth it. But hopefully the United States will do something about that. Just putting a little politics in there. Okay, I think that finishes off our, that finishes off our segment. And good luck out there with your interest formulas.